Yeah, online students, I'm back. There was some confusion because of the power shutdown here. Yeah. So resuming what we were discussing, we were talking about corresponding angles. Okay. So three things. Corresponding angles are formed on the same side of the transversal. One angle is an interior angle, the other is an exterior angle, and the two angles have different vertices. The two angles have different vertices. Children, you both have to be, do your work softly. Okay, they should have different vertices. All right. Okay, now look at angle 1 and angle 6. Angle 1 and angle 6. Angle 1 is an exterior angle, while angle 6 is an interior angle, correct? Both of them are on the same side of the transversal, correct? And they have different vertices. This is the vertex of angle 1, and this is the vertex of angle 6. They have different vertices. Corresponding angles are formed on the same side of the transversal. One angle is an interior angle, the other is an exterior angle, and they have different vertices. Okay, so 1 is an exterior angle, 6 is an interior angle. Both angle 1 and 6 are on the same side of the transversal. And angle, this is the vertex of angle 1. This one, see, this is the angle, no angle, and this is the vertex. This is angle 6, this is angle 6, this is the vertex. They have different vertices. All right. Now, angle 4 and angle 7. Angle 4 and angle 7. Angle 4 is an interior angle. Angle 7 is an exterior angle. Both angle 4 and 7 lie on the same side of the transversal, and they have different vertices. This is the vertex of angle 4, and this is the vertex of angle 7. Some more pairs. Angle 2 and angle 5. Both angle 2 and angle 5 lie on the left side of the transversal. They lie on the other side, the left side of the transversal, correct? The same side, the left side. Angle 2 and angle 5 lie on the left side of the transversal, on the same side of the transversal. 2 is an exterior angle, 5 is an interior angle, correct? 2 is exterior, 5 is interior, right? And then they have different vertices. So 2 and 5, another pair of corresponding angles. And finally, angle 3 and angle 8. Angle 3 and angle 8. Angle 3 and angle 8. Where 3 is an interior angle, 8 is an exterior angle. They lie on the same side of the transversal, and they have different vertices. So we have, so when two lines are intersected by a transversal, we have 4 pairs of corresponding angles. We have 4 pairs of corresponding angles. We also have 4 pairs of alternate angles, of which 2 pairs are alternate interior angles and 2 other pairs are alternate exterior angle. All right. We are already familiar with these terms. That's why I'm using the terms straight away, because it's not that you don't know these terms. We're recalling. You are familiar with the terms, right? Alternate interior angles, alternate exterior angles. So we have 2 pairs of alternate interior angles, or we have 2 pairs of alternate exterior angles. All right. Now, alternate angles lie on either sides of the transversal. Alternate angles lie on either sides of the transversal. On either side, they'll not lie on the same side. On either sides, one angle will be on, like, say, the left side, the other will be on the right side, like that. Okay, so they lie on either side of the transversal. Both are interior or both are exterior angles. See, we have alternate interior angles where both the angles are interior angles. We have alternate exterior angles where both the angles are exterior angles. Alternate angles lie on either sides of the transversal. Again, here also they'll have different vertices. They'll have different vertices. They lie on either sides of the transversal, and both the angles will be interior angles or both will be exterior angles. All right. Okay, so let's identify such pairs from this figure here. So now angle 4 and angle 5. Angle 4 and angle 5. Both are interior angles. Angle 4 is an interior angle. Angle 5 is also an interior angle. They lie on either sides of the transversal. 4 on the right side, 5 on the left side. And they have different vertices. They have different vertices. They have different vertices. Angle 4 and angle 5 lie on either side of the transversal. Angle 4 is an interior angle. Angle 5 is also an interior angle. Both must be interior or both must be exterior. Okay, so 4 and 5 form a pair of alternate interior angles. Similarly, angle 3 and angle 6. Angle 3 and angle 6. Angle 3 and angle 6 both are interior angles and they lie on either sides of the transversal. They have different vertices. Alternate interior angles. All right. Now talking about alternate exterior angles. So two pairs of alternate interior angles. Two pairs of alternate interior angles. Now two pairs of alternate exterior angles. So angle 2 and angle 7. Angle 2 and angle 7. Can you see 2 and 7? 2 and 7 on either sides of the transversal. Both of them are exterior angles and they have different vertices. So 2 and 7 form a pair of alternate exterior angles. Tell me the other pair then. Angle 1 and angle 8. Angle 1 and angle 8. Both of them are exterior angles. They lie on either side of the transversal and they have different vertices. All right. So we identified 4 pairs of. We have some conditions. If a pair has to be called corresponding angles, they must satisfy some conditions. Correct? Yeah. So using the conditions, we identified 4 pairs of corresponding, of which we have 2 pairs of alternate interior angles, 2 pairs of alternate exterior angles. All right. All right. All right. So tell me corresponding angles again. Tell me the pairs of corresponding angles. Angle 1 and angle 6. Then angle 4 and angle 7. Angle 2 and angle 5. Angle 3 and angle 8. Very good. Now alternate interior angles. Alternate interior angles. Angle 3 and angle 6. Then angle 4 and angle 5. Alternate exterior angles. Alternate exterior angles. Angle 1 and angle 1 and angle 8. Angle 1 and angle 8. Then Prenu, another pair. Angle 2 and angle 2 and angle 7. Angle 2 and angle 7. This is what we've seen so far. And now talking about allied angles. Allied angles, also called co-interior angles. Co meaning consecutive. Consecutive interior angles. Co-interior angles. Co meaning consecutive. Consecutive interior angles or co-interior angles, also called allied angles. Okay. So they're called allied angles or co-interior angles. Okay. Now, as the name suggests, co-interior angles. So here, in this pair, both must be interior. Both must be interior because co-interior angle. We also have co-exterior angles, but we don't use that much. We have co-interior angles and co-exterior angles also. But allied angles are co-interior angles. When we say allied angles, we are talking about co-interior angles. We also have co-exterior angles. We don't use that much. We don't find it in the textbooks also. But there is something called co-exterior angles also. Fine. Okay, now we are going to talk about allied angles, which are co-interior angles. Both of them must be interior angles. That is angle 4 and angle 6. Angle 3 and angle 5. They should lie on the same side of the transversal. Allied angles lie on the same side of the transversal and both of them are interior angles. Because if they lie on opposite sides of the transversal, then they'll become alternate interior angles. Then they'll become alternate interior angles. That is the difference between alternate interior angles and co-interior angles. Co-interior angles or allied angles, both are interior angles and both will lie on the same side of the transversal. So angle 4 and angle 6 and angle 3 and angle 5. You understand? 3 and 5, 3 and 5. Both of them are interior angles and they lie on the same side of the transversal. Correct? Angle 4 and angle 6 lie on the same side of the transversal and both are interior angles. So 4 and 6, 3 and 5 form the pairs of allied angles or co-interior angles. Now talking about co-exterior angles, tell me, you can guess co-exterior angles. 2 and 8, angle 2 and angle 8. Then angle 1 and angle 7. So these are the different relations we find when two lines are intersected by a transversal. All right. When two lines are intersected by a transversal, we have corresponding angles being formed, alternate interior angles being formed, alternate exterior angles, allied angles, also called co-interior angles. We have co-exterior angles. Now all these angles are formed, that's all. Now when these two lines are parallel to one another, then, so now this is the case where the lines are not parallel. They are simply two lines intersected by a transversal. The lines are not parallel. Okay. Now, if the two lines are parallel, if the two lines are parallel, if the two lines are parallel, then the corresponding angles are equal. Here, the corresponding angles are not equal. When the lines are not parallel, angle, all these angles are corresponding angles. That's all. They're just corresponding angles. They're not equal. When L is not parallel to M, whatever we have mentioned here, they are corresponding angles. These are alternate interior angles. These are alternate exterior angles. These are allied angles. These are co-exterior angles. All that is there. But when the lines are not parallel, corresponding angles are not equal. They're not equal. When the lines are parallel, corresponding angles are equal. So when the lines are parallel, here in this case, where L is parallel to M, L is parallel to M, the corresponding angles are equal. That means angle 1 is equal to angle 6. Angle 1 and 6 are corresponding angles and they are equal. Here, angle 1 and 6 are corresponding angles. That's all. Here, angle 1 and 6 are corresponding angles and they are equal. Then, angle 4 is equal to angle 7. Here, angle 4 and angle 7. Angle 4 and angle 7. They are corresponding angles. That's all. The lines are not parallel. So the angles are not equal, but they are corresponding angles. The relation exists. The name exists. They are corresponding angles. But they are equal only when the lines are parallel. When the lines are not parallel, they are not equal, but they are corresponding angles. Okay. So similarly, angle 2 is equal to angle 5 and angle 3 is equal to angle 8. All right. Now alternate interior angles. Alternate interior angles are also equal. When the lines are parallel, angles are equal. So angle 3 is equal to angle 6. Angle 4 is equal to angle 5. Understood? Angle 3 is equal to angle 6. Alternate angles are equal. Alternate exterior angles. Alternate exterior angles. Angle 1 is equal to angle 8. Angle 2 is equal to angle 7. Why they equal? Because the lines are parallel. Here the lines are not parallel. The lines are not parallel. So they're just alternate. They have the name, but they're not equal. They're called by that name, but the angles are not equal. All right. Are you trying to write something? What's your name? Sorry? Okay. All right. Oh, okay. Yeah, you can. Yeah, you can also stop working. Bye. You're practicing now for the exam, so you should write. Okay, thank you, Satakshi. Bye. You're going by yourself, right? Okay. Yeah, children. Yeah, okay. You can just leave it. Yeah. Now talking about allied angles. Allied angles. All right. Now allied angles are not equal. Allied angles are supplementary. Co-interior angles are supplementary. Angle 4 plus angle 6 is equal to 180. Angle 3 plus angle 5 is equal to 180. Corresponding angles are equal when the lines are parallel. Alternate angles are equal when the lines are parallel. Allied angles are supplementary when the lines are parallel. Allied angles are supplementary when the lines are parallel. Thank you. See you. Alright. Similarly, co-exterior angles, they are also supplementary when the lines are parallel. That is angle 2 and which one? 8. Angle 2 plus angle 8 is equal to 180. Angle 1 plus angle 7 is equal to 180. When the lines are parallel, sorry to disturb. Okay, you will go. So when the lines are parallel, corresponding angles are equal, alternate angles are equal, co-interior angles are supplementary, co-exterior angles are also supplementary. Is that understood? When the lines are not parallel, all those names exist. When the lines are not parallel, all those names will exist, but the angles are not equal or the angles are not supplementary, as the case may be. No, that one does not exist. When the lines are parallel, then corresponding alternate angles are equal and co-interior, co-exterior angles are supplementary. Is that fine? All right. Now, I'm not able to hear anything from the online students. Yeah, students, somebody online tell me, pick out the pairs of vertically opposite angles. Vertically opposite angles.
Angle 2 and angle 4, ma'am.
Angle louder, Swati.
Angle 2 and angle 4, ma'am.
Angle 2 and 4, then
Angle 1 and 3.
1 and 3.
Angle 5 and angle 7.
5 and 7.
Angle 6 and angle 8, ma'am.
Angle 6 and angle 8. Angle 6 and angle 8. Vertically opposite angles. Vertically opposite angles. So vertically opposite angles and parallel lines have no connection. Vertically opposite angles are formed when two lines intersect. When two lines intersect, vertically opposite angles are formed. So there's nothing between when two lines or when parallel lines are intersected by a transversal, what are generated corresponding angles, alternate angles, co-interior angles, co-exterior angles. These angles are generated when two lines or when two parallel lines are intersected by a transversal. Vertically opposite angles are there wherever two lines intersect. Wherever two lines intersect, vertically opposite angles will be formed, and they're equal. So here can you see there is one line here like this, and there's another line here like this. So two lines are meeting and vertically opposite angles are formed and they're equal. When two lines, can you see the line L and line T, they meet here. So vertically opposite angles are formed. Angle 1 is equal to angle 3, angle 2 is equal to angle 4. Similarly, line M and line T. Line M and line T. This is line T. This is line M. They intersect. So angle 6 is equal to angle 8. Not because the lines are parallel. Here also they're equal. Here also vertically opposite angles are equal. You see here L is not parallel to M. Here also angle 1 is equal to angle 3. Angle 2 is equal to angle 4 because vertically opposite angles are equal. When two lines intersect, vertically opposite angles are formed and they're always equal. Now here you should not say that the lines are not parallel. So angle 1 and 3, they are vertically opposite angles, but they are not equal because the lines are not parallel. Vertically opposite angles and parallel lines are not connected at all. So here these two lines L and T, they intersect. So angle 1 is equal to angle 3. Vertically opposite angles are equal. 2 is equal to 4. And here also 6 is equal to 8. 5 is equal to 7. Here also they're equal because two lines intersect. And then what else? Here also we have linear pairs. So linear pair also, wherever you have a straight line and two angles on it. Okay, so here do you see a straight line L? Yes. And can you see two angles on it, 1 and 2? Yes. 1 plus 2 is 180. Why? Because it's a straight angle. This is a straight line. This is a straight angle, 180 degrees. So angle 1 plus 2 is equal to 180. So linear pair is not nothing. Linear pair has nothing to do with parallel lines. This is a straight line. So angle 1 plus 2 is equal to 180. Now see, this is a straight line. So angle 2 plus 3 is 180. Angle 3 plus 4 is 180. Angle 1 plus 4 is 180. Here also, linear pair. When two angles stand on a straight line, see here, T is a straight line. T is a straight line. Can you see these two angles? 1 and 4. They stand on the straight line. 1 and 4. So 1 plus 4 is 180. See this again T. On the other side, you have 2 and 3. 2 plus 3 is 180. Below you have, this is the line L. Below L, you have 3 and 4. 3 plus 4 is 180. On a straight line, when you have two angles, the sum of the angles will be 180. And that's what we call it as a linear pair. When you have a straight line and a ray on it, this angle plus this angle is 180 because this is a straight line and this is a straight angle, which is 180. So this angle plus this angle is 180. So here we have 5 plus 6 is equal to 180, 6 plus 7 is equal to 180, 7 plus 8 is 180, 5 plus 8 is 180, linear pair. Okay, so linear pair exists wherever we have straight lines. And see, it's actually when we have a straight line and a ray stands on it. This is the straight line and this is the ray kind of. This is the straight line, this is the ray. So 7 plus 8 is equal to 180. So like that. Okay, so linear pair and then vertically opposite angles are equal. All right. So you have to check if lines are parallel or not parallel only for corresponding alternate and allied angles. If you find a pair of corresponding angles, if the lines are parallel, then the corresponding angles are equal. If the lines are not parallel, they are corresponding angles, but they are not equal. When you find alternate interior angles, if the lines are not parallel, alternate interior angles are not equal. But they are alternate interior angles, but they're not equal. When the lines are parallel, alternate interior angles are equal. Similarly, allied angles are supplementary. What is distracting you, Mohit? Is he drawing something else? Allied angles, they are supplementary if the lines are parallel. They are not supplementary when the lines are not parallel. But they are allied angles. All right. So when you're given a figure with some information and asked to find the missing angle or angles, you should use all this. You must check for vertically opposite angles, linear pair. Okay, angle some property in a triangle. I haven't told you that. I'll tell you. So then these angles corresponding alternate allied angles. You must think of everything to answer. See, when you're given a figure with some information and asked to find an angle, a missing angle or missing angles, you should use all these ideas. All right. one thing which I missed is about exterior angle property of a triangle. Exterior angle, I told you notes I'll give you, don't write anything now. So exterior angle property in a triangle. Triangle, this side is produced. So when a side of a triangle is produced, exterior angle is formed. When a side of the triangle is produced, then the exterior angle is formed. So now see, these are the interior angles. These are the interior angles of the triangle. Angle 1, angle 2, and angle 3 are the interior angles of the triangle. Now this is the exterior angle 4. Now what makes a linear pair? 3 plus 4 is equal to 180, no? 3 plus 4 is 180, right? Linear pair. 3 plus 4 is 180. So leave this 3. Angle 4 is equal to angle 1 plus angle 2. Angle 4 is equal to angle 1 plus angle 2. Exterior angle is equal to the sum of the two interior opposite angles. Exterior angle is equal to sum of interior opposite angles. Interior opposite angles. See, this is the exterior angle. This is the immediate interior angle. Leave that. Take the other two. Angle 4 is equal to angle 1 plus angle 2. The triangle has 3 angles in it. Now, the exterior angle, for that exterior angle, there is an interior angle just adjacent to it, right? Leave that angle. The exterior angle is equal to the sum of the remaining two interior angles. See. This is an exterior angle. This is the interior angle. Leave this. This angle is equal to this angle plus this angle. Triangle. If this side is produced, exterior angle is formed here. Now this exterior angle is equal to, leave this interior angle. This exterior angle is equal to this angle plus this angle. All right. If the side is produced like this is the exterior angle. This one is the exterior angle. This is the interior angle. Leave this one. This angle is equal to angle 1. Angle 1 is equal to this angle, angle 2 plus angle 3. This is the exterior angle property. We have the proofs for all this. We'll do them later. Angle sum property, you know, the sum of the 3 angles in a triangle is equal to 180. That we know. So again, when you have to find the missing angle or missing angles from the figure, you must think of linear pair, vertically opposite angles, exterior angle property, angle sum property, alternate angles, corresponding angles, allied angles. One of this will work. One of this or a combination of these will help you to find the answer. All right. Online students. Can we proceed? Any questions?
No doubts, ma'am.
No, miss.
Okay. Yeah, start working from here. You don't have to leave space and all that. You can just fill in the introduction notes later. Take down this figure. We'll start working from here. All right. So here you understand that these arrows indicate parallel lines. The arrows indicate parallel lines. Okay, so here AB is parallel to CD. It's not given in words, but from the way the arrows are marked, it's understood that AB is parallel to CD. All right. Okay. And then some measures are given to you. This angle is 104 degrees. This one is 116 degrees. And this is what you'll have to find, X. All right. Now, let me quickly show you here how it is to be found. All right. Now, you need to take up a construction. I'll tell you why construction also. Why construction? That I'll tell you. Now, through this point, you should draw a line parallel to this line or this line. See, when you have one line, can you draw another line parallel to this? It's possible, no? When you're given one line, you can draw so many lines. You can draw so many other lines, but there is only one line which can be parallel to the given line. When you have one line, you can draw so many lines like this. You can draw so many lines, but of those many lines, there can be only one line which is parallel to the given line. So now this is the line. Supposing this line, through this point, we are drawing that line which is parallel to this one. That's possible to draw. See, construction is something which is possible. It's not something you wish. I want to do this. You want to do it, but is it possible to do that? It should be possible. Construction should be possible. Possible meaning you should justify your construction. So we have this point. We have this point, and through this point, you can draw so many lines. Through this point, you can draw a line like this. You can draw a line like this. You can draw a line like this. Through this point, you can draw so many lines. But of those many lines, there'll be only one line which can be parallel to this line. That line we are taking as the construction. All right. Okay. So this is that line. So we say construction through this point, draw. So here it is through E. Okay, so through E. Okay, draw this line parallel to this one, parallel to this line AB. Okay, so this is AB. So say we draw EF. We draw EF parallel to AB. Construction, draw EF parallel to AB. All right. But we already have AB parallel to CD, correct? AB is already parallel to CD. AB is parallel to EF by construction. But AB is parallel to CD given in the question. So when you compare these two, AB is parallel to EF, AB is parallel to CD. So there is a theorem which says two lines parallel to the same line are parallel to one another. So here the two lines are EF and CD. EF and CD are the two lines. They are parallel to the same line AB. So they are parallel to one another. That means EF is parallel to CD. Therefore, EF is parallel to CD. I'm going to tell you this one again. I'll tell you this again. The theorem is two lines parallel to the same line are parallel to one another. Okay. AB is already parallel to CD. Is given in the question. AB parallel to CD, we already know. Construction is we draw EF parallel to AB. That is a construction. We draw EF parallel to AB. That's a construction. Now, when you compare these two, the two lines CD and EF are parallel to the same line AB. So they are parallel to one another. Therefore, by the theorem, CD is parallel to EF. CD is parallel to EF. CD is parallel to EF. All right. So now all these three lines are parallel to one another then. All these, because AB is parallel to EF, EF is parallel to CD, and AB is parallel to CD. So all the three lines are parallel to one another now. Now, take these two lines, AB and EF. They are parallel. And this is the transversal. Okay. These two are the parallel lines. And this is the transfer. You can produce the lines to understand better. See, you can produce it like this. So you can see AB is one line, EF is the other line, and this is the transversal. And this one is 104 is given in the figure. This one is 104 is given. Now, allied angles are supplementary. When two lines are parallel, co-interior angles are supplementary. So this angle and this angle, they are co-interior angles. See, here, take the figure separately. Two lines transversal. See at this angle and this angle. They're allied angles. And allied angles are supplementary. Okay, so I'm going to mark this angle as A. So you should write 104 plus A is equal to 180 because they're allied angles. So their sum will be 180 because the lines are parallel. So like this, you can find A. A is equal to 76 degrees. Now we know that this is 116 degrees. Mark this angle as B. Now what do you have here? EF is parallel to CD. EF is parallel to CD, and this is the transversal. This one is a transversal. See, it's very important to identify the parallel lines and the transversal. This is EF, this is CD, and this is the transversal. This is the transversal. EF parallel to CD, and this one is a transversal. Again, this angle and this angle, they are allied angles. They are supplementary. This one is 116 degrees. I've marked this as B. So 116 plus B is equal to 180. So B is equal to 64 degrees. B is equal to 64 degrees. So now what is X? X is equal to A plus B. X is equal to A plus B. This is X. And what is X? This is X. This one fully is X. What is X? A plus B. So X is equal to 76 plus 64, which is 80 plus 60, 140 degrees. All right. Yeah, now I'll write it. You please write it along with me. If you have any questions, you can ask me later. Don't write by yourself. Please take down whatever I write. So draw the figure again. In the solution, draw the figure again. Don't mark X. Don't mark X. So you must write construction through E. Through E, draw EF parallel to AB. Parallel to AB. Now, EF is parallel to AB. But CD is also parallel to AB. Finish writing. So how will you finish the answer? We found A and B. Now how will you find X? A plus B. X is equal to A plus B. I'll write it here, children. I'm writing it here. Therefore, X is equal to A plus B. I'm finishing the answer here. A plus B, that is 76 plus 64. So X is equal to 140 degrees. I'm completing the answer here. I'll show you the angles again. How they are allied angles, I'll show you again. Done writing? Online students? Okay. Finish writing here, all of you. Dear children, the figure is like this. The figure is like this. This is our construction. This is our construction. Just produce to like understand the figure better. Just produce the lines. This is one transversal. So see, these are the two parts. This one, this line and this line. These are the two parallel lines. This is the transversal. So can you make out this angle and this angle? They're allied angles. It's like this, two parallel lines and transversal. This one and this one. They're allied angles. That's what you see here. Between 104 and A. They're allied angles. If you produce, when you produce the lines, you can understand better. Just produce it like this. Produce it. Produce the figure. Meaning produce the lines. Then you can make out 108, 104 and A are allied angles. They're supplementary. The same with the other one. This one below. Produce the lines. These are the two parallel lines. This one and this one. These are two parallel lines. This is the transversal. The transversal is different. This is the transversal. So this angle and this angle, they're allied angles. Allied angles are always like this. For allied angles, see here, this and this, right? See, one arm will be the parallel line. The other arm will be the transversal. See here, one arm is the parallel line. The other arm is the transversal. One arm of the angle is the parallel line. The other arm is the transversal. You can see that here. Okay, so see here, 104. This is the parallel line. This is the transversal. The same transversal and the other parallel line. See, if you darken that also, you can make out. Always mention the parallel lines and the transversal. Don't take a pair of lines that is a set of parallel lines and only one transversal at a time. Don't see with two transversals. Two parallel lines and one transversal. That's why in the answer I've mentioned these are the two parallel lines and this is the transversal. That's how you should start. Mention the parallel lines and the transversal, and then you say what angles you've identified, allied angles or corresponding angles, whatever you've identified. So the transversals are different. In the first case, AE is the transversal. In the second case, EC is the transversal. Okay, now where to draw the construction? The construction is normally in 99% of the cases, we see, okay, in this figure, we have four line segments, right? AB, CD, AE, and CE. In this figure given, we have four line segments or lines, whatever you call them. We have AB and CD, which are parallel. Leave that. What are the remaining two? AE and CE. Are they parallel? No. They're meeting somewhere. No. So we are treating AE and CE as a transversal. Those two lines which are not parallel. Leave the parallel lines AB and CD. The other two, AE and CE, they are like the transversals because they're not parallel. They're like the transversals. Where do they meet at E? Through that point, we draw the construction. I'll give you another example to make it more clear. Now, supposing you have a figure like this. Supposing these two lines are parallel. Suppose these two lines are parallel. And there are two things which are meeting like this. These are the two parallel lines. This one and this one. These are the two parallel lines. Okay, now we have two other line segments in this figure. Second. We have two other line segments in this figure. Trying to make it neat. Yeah. Now we have two other line segments. See here like this. Where do they meet? They meet here, no? So the construction will come through this point. Now through this point, we have to draw a line parallel to this one or parallel to this one. The construction is usually through that point where the two transversals meet, the so-called transversals meet. Normally in these figures, you can identify four line segments or four lines, whatever. Two of them will be parallel, no, leave those two lines. Take the other two. Though the other two, they'll meet somewhere. So here, these are the other two. They meet here like this, they meet here. That means the construction will go through this one. Through this point, you should draw a line parallel to this line or parallel to this line. That's what we've done here. AE and CE, they meet at E. So through E, we draw a line parallel to AB or we draw it parallel to CD. And yeah. You just have to practice to understand better, children. Okay, I've done my part. A similar question. Yeah, so the question is find X. The question is to find X. You can write Mn also. No, I'm confused. Tell me which is the transversal here. How do we find A and B? To find X, we're going to find A and B. Yeah, how do you find which is the transversal? If AB is parallel to MN, which one should be taken as a transversal? B? BO is a transversal. Very good. BO is a transversal. BO is a transversal. Yeah, now what is the relationship between 35 and A? 35 and A. 35 and A, how are they related? See, they're like this. No, see, the figure is like this. Just produce it. Produce the lines. Produce the lines and see. How do they look? Alternate interior angles. Alternate interior angles. Produce the lines and see. You can just produce them. See two lines. This is a transversal. 35 and A lie on either sides of the transversal. 35 and A, they lie on either sides of the transversal. So they're alternate angles and both of them are interior angles. So alternate interior angles. So AB is parallel to MN and BO is a transversal. Okay, let's understand the angles better. See, Alternate angles are, you're still writing, Laksha? Finish? Okay. Alternate angles are found in the Z like this. No, last class I think we were talking about this when I gave you some 2 questions on lines and angles. Yes. So you can, so like this, take a Z and rotate it. Take a Z and rotate it in all possible ways. So see here and here are the alternate interior angles. Here and here are the alternate interior angles. Alternate interior angles. Alternate interior angles. These are the two parallel lines, and this is the transversal. These are the two parallel lines. This is the transversal. These are the two parallel lines. This is the transversal. These are the two parallel lines. This is the transversal. Alternate angles are found in these two places, alternate interior angles. Co-interior angles, you'll find a C kind of thing like this here. These are co-interior angles. Co-interior angle is like C, no? Co-interior C. So normally it looks like that C only. Rotate this. So it can be like this also. It can be like, like parallel lines. And if this is the transversal, this one and this one. If these two lines are parallel, you can take this as the transversal. These are co-interior angles. C, rotate that C. Rotate C. So like this also, you can find alternate angles like this also. Sorry, co-interior angles. Co-interior angles. This one and this one are co-interior angles. If these two lines are parallel, this one is a transversal. So a C kind of a thing, and you keep turning it. However it looks, these two angles are co-interior angles. So alternate interior angles are in this kind of a shape, Z or Z rotated. Co-interior angles, so it can be like this also. This one and this one, co-interior angles, allied angles. Corresponding angles are normally in the shape of an F like this, like this. These are the two parallel lines. This is the transversal. Same side of the transversal, one interior angle, one exterior angle. One interior angle, one exterior angle. So something like an F. Or turn the F. Turn that, rotate it by 360 degrees. However, that F looks like, no? So it can be like this also. These are the two parallel lines. These are the two parallel lines. This is the transversal. Here and here are are corresponding angles. Corresponding angles. Corresponding angles F shape. Alternate interior angles Z. Co-interior angles or allied angles C. Co-interior angles. So C. CO. So C. Co-interior angles or allied angles C. Alternate interior angles Z. Corresponding angles F. So you can see here alternate angles. You can see here. See here. Parallel line. Transversal. Parallel line. Can you see the Z now? On the board. Can you see the Z? See here. Parallel line. Transversal. Parallel line. Can we see the Z? Not on the floor. Not on my face. Not on the ceiling. On the board. And Lakshas, this is not a big joke. I'm not teaching you how to write Z. Okay, so see here, parallel line, see, parallel line, transversal, parallel line, like that it is. So see here, parallel line, transversal, parallel line. So 35 and A, alternate interior angles. Now again, see the Z here, parallel line, transversal, parallel line. Can you see that? Parallel line, transversal, parallel line, like this it is. Parallel line, transversal, parallel, like this. So here and here are alternate interior angles and they're equal because the lines are parallel. All right. See the corresponding angles here? No, this was allied angle. See that C here? Allied angle. See here. Parallel line, transversal, parallel line. That's C. Here we use allied angles, right? So see here, parallel line, transversal, parallel line, the C. Parallel line, transversal, parallel line, the C here. Below also, parallel line, transversal, parallel line. Can you see the C here and here? Allied angles. So it's easy to make out. So in both these cases, we had to take a construction, and the construction is drawn through that point where the two lines which are not parallel meet. Of the four lines, you see, two of them are parallel. Leave those two lines. The remaining two lines, they meet somewhere, no? Through that point, we draw a line. That's the construction. Now, this is a test. Yeah. Fine, next children. Online students, use the emoji. Raise your hand. Pranav, Sahana, Swati, Anugraha, Aragamai, Aniruddhan, and Niveda. Okay, thank you, children. All of you are comfortable today? Not hearing much from online students. Okay, solve this and let me know. Make me believe that, or make me confident that, you have understood. Do this correctly and tell me the answer. Got it? Not drawn the figure at all. Where is A? Which is A? No, you may be right, but I don't. You have not drawn the figure. You have not marked anything, so I can't make out. Both is the figure construction of array. No? Construction of array. No, you may be right, but you've not drawn the figure, so it's not easy for me to understand. What's the answer? 32. Okay. Yeah, online students. Hari Pranab. Anirudhan. Yes, Niveda.
I got the answer as 100.
100. Huh?
Yes, ma'am.
Okay.
Similar answer,
That's
ma'am. 100 degrees.
Swati also got 100. Okay. Hari Pranav. Anirudhan.
Was doing.
Okay. No, we'll do it together. Hari Pranav. I'll just draw the
Okay.
figure again. Tell me the construction. Oh shit.
Ma'am, 48.
48. Huh? Okay, let me see. I don't know. I don't have the answer. Yeah, Hari Pranav, what's your first step? Construction through?
Answer through beams.
Very good. Through P, draw
Draw MNs.
MN. Okay, so let me mark M here, N here. So construction through P, draw MN parallel to?
A beam.
Very good. Parallel to AB. Very good. That's the first step. So that means we have MN, you can write MN parallel to AB or AB parallel to MN, anything. Order and all is not important here. Anyways, you can write. So we have MN parallel to AB by construction. But what is that we already have in the question, Hari Pranav?
Because AB is parallel to CD.
Yeah, AB is parallel to CD. AB is parallel to CD, we already have in the question, that is given. So by comparing these two, AB is common in both. AB is common in both. MN and CD are two lines which are parallel to the same line AB. MN is parallel to AB. CD is also parallel to AB. The two lines MN and CD are parallel to the same line AB. So they are parallel to one another. This implies MN is parallel to Hari? CD. What's the theorem, Hari? Two lines. Hari, complete the theorem. Two lines. two lines parallel to the same line are parallel to one another.
Okay.
Yeah, two lines parallel to the
Parallel to one another are
no,
same.
no. 1 minute, 1 minute. Okay, 1 minute. If A is parallel to B and A is parallel to C, see here, B and C are two lines. Two lines. Okay, B and C are two lines. Two lines parallel to the same line A. Parallel to the same line. Correct? Two lines, that is B and C. They are parallel to the same line A. Two lines parallel to the same line are parallel to one another. That means these two lines, they are parallel to one another. B is parallel to C. Okay. Two lines parallel to the same line are parallel to one another. Okay. All right, very good. So I'm not completing that. I'm just writing two lines and dots. Okay, don't do this in the exam. You have to write it fully. Don't put the dots. Yeah. Now take two. Now we have like we have found out some parallel lines. Identify the respective transversals. Yeah. Now first we'll take AB parallel to MN. MN parallel to AB, AB parallel to MN, both are the same. AB parallel to MN, which is the transversal? Hari?
Miss AP.
AP is the transversal. Very good. AB parallel to MN and AP is the transversal. AP is the transversal. Yeah. Now, what is the relation between 132 and A? Hari Pranav, maybe you've written something else in your book. It's okay. Now you answer my question. What is the relationship between 132 and A?
Miss, they are alternate interior angles. Miss.
Where is the Z? See here. Is it a Z or a C?
The seams.
It's a C. So what are they?
Allied angles.
They're allied angles. They're allied angles. So one, see here. Parallel line, transversal, parallel line. You just produce it and see. Produce the parallel lines. Produce the transversal. Here, these are the two angles. They are allied angles.
Yes.
Okay. Yeah. So 132 is equal to A. What should you write?
132 plus A is equal to 180.
Very good. 132 plus A. Plus A is equal to 180 because allied angles are supplementary. Allied angles are supplementary. 132 plus A is equal to 180. So what is A, Pranav? 180 minus 132. What is A? 48 degrees. Correct?
Yes, miss.
Very good. Now tell me, Pranav, how will you find B?
Miss, first CD is parallel to A.
No. Pranav, what is A plus B?
The angle X.
What is the value of A plus B?
$118.
No, darling. What is A plus B? Look at the figure given and look at A plus B we have marked and tell me. What is A plus B? See the figure given in the question and see where we have marked A and B. What is A plus B? Aniruddhan?
Ma'am, 148, ma'am.
That was not Aniruddhan. Who was that?
Ma'am, Sahana, ma'am.
Sahana. Okay, good. Sahana. Okay. Aniruddhan, are you there?
Yes, ma'am.
Okay, what is A plus B?
Ma'am, 1 minute, ma'am.
Okay. Anirudhan, see here in the figure. Look at the screen, Anirudhan. This is the construction, right? Can you see? This is the construction, right, Anirudhan? நம்ம அந்த construction பண்றதுனால 148 degrees தானே split ஆகுது A and B ஆ. அது ஈக்குவலா A and B will not be 148/2. That angle 148 degrees, because of the construction, that angle 148 degrees is split into 2. At that point P, we have 148 degree. Because of the construction, that 148 degree angle is disturbed. That angle is disturbed. It's now split into 2 angles. One goes above the line, one comes below the line. That 148 is now disturbed. Earlier it was good. 148 you could see. Because of that line, construction line, 148 angle is disturbed and it's split into 2 angles. And we marked it as A and B, correct? The upper part is A and the lower part is B. So A plus B is 148 degrees. Anirudhan, yes or no?
Yes, ma'am. Sorry,
It is
ma'am.
not. It's not allied angles or anything. Nothing. No property. It is given in the question. A plus B is equal to 180 because due to the construction, 148 degrees is disturbed. It's split into 2 angles, which we have marked as A and B. So A plus B is 148 degrees. What is A? 48. Sorry, A is 48 we found. So 48 plus B is equal to 148. So B is equal to 148 minus 48. B is equal to 100 degrees. Yes or no? B is 100. Every sum is different in working. It's not exactly like what we did earlier. B is 100. Now, what is the relationship between B and X? There's X here. What is the relation between B and X? Can you see the F form there? Can you see the F form there? Can you see the F? See this? See the F? See the F? This one, the transversal here. And then can you see that F? One angle here and one angle here. Yes or no, children? Can we see the F there? In that F, you know, these two should be the no, don't disturb others like this. These two should be the parallel lines. These two should be the parallel lines. In the F, these two should be the parallel lines and this one the transversal. So here and here are corresponding angles. Corresponding angles here and here. See that. See here? Parallel line. You can see the F here. First, I'll show you the F. This is the F. And you can see the angle here B and X. B is equal to X. Corresponding angles are equal because the lines are parallel. Okay, so that's it. So now you should mention the parallel lines. PN parallel to CD, PN or MN parallel to MN parallel to CD. And who's the transversal? Who's the transversal? Online students? Who's the transversal?
CP.
PC. PC is the transversal. PC is the transversal. Angle B is equal to, B is equal to X. Or you can write X is equal to B. X is equal to B. Because corresponding angles are equal. So X is equal to B, we just found 100 degrees. B, X is equal to 100 degrees. X is equal to B and B we found is 100. So X is equal to 100. Complete the answer. You have vacations, huh? Next week is from today to 3rd. No vacations, no. That's one thing good about Montfort School. They still follow the earlier system of, test, half yearly exam, yeah, vacation. And for 9th standard also, they'll have exams only in March, while other schools will start off from December, Jan. We'll keep finishing, but they'll finish only by March end. So mostly they don't hurry up like the other schools. Finish writing, children? Mohat, have you taken down everything on the screen in your book? All of you? The girls are entertained actually. They're having fun with maths. Fun because you are doing something. All right. The answer ends here. The answer ends here. All right. So talking about this figure again. This is how it was, right? So this is the construction, correct? This angle 132 degrees, correct? This whole thing was 148. Adha nama eduthitom. A being put on other. Correct? Now 132 plus A is equal to 180. 132 and the 148 angle use pannala. 132 plus A is equal to 180. So what is A? 48 degrees. Ipo, this is 48. And the full angle level 148. In angle, allied angles, using allied angles, this one is 48. But the whole thing was given in the question, no, the whole thing is 148. In the clear triangle, 100. Yes or no? We didn't use at 148 at all. We, with the help of 132 degrees, we found this one, allied angles. So we got 48 here. But this whole angle is given in the question as 148. And this one is 48. So the remaining angle has to be 100. That's one part of the answer. That's what we have to write like this. We found A. A is 48, but A plus B is 148. A is 148, but A plus B is 148. That is not any property. Okay, that's not any property. A is 148, but A plus B is 148. So B is 100. Now B and X corresponding angles. B and X, this angle and this angle corresponding angles. These two angles corresponding angles. Why? Parallel line, transversal, parallel line. These two are the parallel lines. This is the transversal. This angle and this angle are corresponding angles and they're equal. You can see that here. Parallel line, transversal, parallel line, this angle and this angle. So B is equal to X. So B is 100 degrees. X is also 100 degrees. Corresponding angles. No, see, I'll tell you one thing. I don't like to waste time taming people, you know. I'm here to teach, not to tame people. Why do you have to look back constantly? If you're getting distracted, come bench முன்னாடி போன்னு உட்காந்துக்கோ. What is it you have to turn back and look? Is somebody disturbing you? Tell me. You also. Why do you keep looking around? No, I don't want to talk anything else other than math in the class. So this is the next question, children. This is 4. Yeah, take down the figure. I'm just giving you similar questions. So don't get fed up. Find X. See, this line is higher. CD is higher. AB is lower. They're parallel. Like when you produce them like this. This one, and this one, they're parallel lines. Parallel, they're parallel. See, I'm going to show you with the dotted lines here. This is CD. And it's parallel to AB. So this is the given figure, and we have to find the measure of X. So as I told you, AB and CD are marked parallel. Leave those two lines. The other lines are BO and CO, which meet at O. BO and CO, which meet at O. So the construction should go through O. Through O, draw a line parallel to AB or CD. All right? Okay. Draw the figure again, all of you. Draw the figure again, all of you. Solution figure. This is a question figure. Draw the solution figure again. Or I'll use the same figure. No? Exception for me. Or if you kindly draw the figure again for the solution, don't make the changes in the question figure, then you will not know the information given in the question and what construction you did. Don't do the changes in the question figure itself. Okay, now I am going to use a question figure. The construction is through O. Through O, draw XY, say XY. Through O, draw XY parallel to any one of the two lines, AB or CD, any one. Anybody you can say AB. So that means now we have AB parallel to XY by construction. But AB is parallel to CD is given in the question. Two lines parallel to the same line are parallel to one another. So XY is parallel to CD. Now can you see the C? AB, BO transversal and OX like this. Can you see this? Can you see AB here? BO transversal and OX. See, this one is parallel to this one. These two are parallel. BO is a transversal. This one is 120 degrees. Now we'll mark this as A. What is the relation between 120 and A? What kind of angles are they? Co-interior angles or allied angles. Can you see that C here? Ulta C. AB, transversal and OX. Right, all of you, what will you write? AB parallel to OX, or you can write XY also. OX, XY, all the same. AB parallel to XY, or you can write OX. And BO is the transversal. I'm not writing that, write it. AB parallel to OX or XY. BO is the transversal. 120 plus A. 120 plus A is equal to 180. Said something? 180. So A is equal to 60 degrees. So we found A. Next we have to find. We'll mark this one as B. We'll mark this as B. And look at the figure. We have CD. We have the transversal. And we have OY like this. So CD, CO, OY. So here we have 110. And here we have B. So again, CD parallel to XY and CO is the transversal. CD is parallel to XY. All that we have here, CD is parallel to XY. We have proved all that. Parallel lines, we have proved everything. 3 sets of parallel lines we have. One is given, one is construction, and by comparing the given and construction, we got a new one. We have 3 sets of parallel lines. We are using them only. So CD parallel to OY and CO is a transversal. 110 degrees plus B is equal to 180. So B is equal to 70 degrees. Now Mohit, how will we find X? Mohit, we found A and B. Tell me, how will we find X? Okay. Yeah, and then 180 minus that. Okay, that's right, but and something else? Is XY a straight line? Yeah, it is. That's a construction. We draw a line, no? So it is a straight line. So at the point O, how many angles are there on the straight line? On the straight line XY, at the point O, how many angles can you see? Huh? 3 angles. What are they? A, X, and B. These 3 angles stand on the straight line, right? So what will be the sum of these 3 angles? 180. I think we can do that directly. So A plus X plus B is equal to 180 because these 3 angles, they stand on the straight line. A plus X plus B will be 180. This is not linear pair. Linear pair is only 2 angles. This is not linear pair. Don't write linear pair. Sum of the angles on a straight line is equal to 180. Reason is sum of the angles on a straight line is equal to 180. So 60 plus X plus 70 is equal to 180. X is equal to 180 minus 130. X is equal to 50 degrees. All right. Yeah. Done, children? Okay. We'll work this and wind up the session for today. Yeah, give a name to this figure. Name the figure. Yeah, I want a name for this figure. Name this figure. Hmm. Is it a triangle?
Quadrilateral, ma'am.
Sorry?
Ma'am, it's a quadrilateral.
It's a quadrilateral. More specifically, what? Can you give an additional? It's a
Concave polygon.
very good, Swati. It's a concave quadrilateral. It's a concave quadrilateral. Yeah. So how do you find the measure of this angle X? Okay. So as usual, angle some property. We have different ways of doing it. We have different ways. We'll see the others in the next class. I'll just do one of it now. So let me mark this angle as A. Let me call this A. Let me call this A. Actually, you should draw the solution figure and there you should mark it as A. So now we know in a quadrilateral, the sum of the four interior angles is 360 degrees. Whether it is a concave quadrilateral or convex quadrilateral, if it's a quadrilateral, the sum of the four angles will be 360 degrees. In a triangle, the sum of the three angles is 180 degrees. In a quadrilateral, whether it is convex or concave, the sum of the four interior angles is equal to 360 degrees. So here 55 in concave, you don't have to mention concave, you can just say in quadrilateral ABCD. In quadrilateral ABCD, 55 degrees plus 30 degrees plus 45 degrees plus A, the sum of the four interior angles. The sum of the four interior angles is equal to 360 degrees. 130 plus A is equal to 360. A is equal to 360 minus 130. A is equal to 230 degrees. Now, A plus X is equal to 360 because it's a complete angle. A and X put together is a complete angle. Yes or no? Around the point D, around the point D, we have A and X. We have A here and X here. A plus X is equal to 180 degrees. Sorry, A plus X is equal to 360 because sum of the angles around a point is equal to 360 degrees. A plus X is equal to 360. 230 plus X. 230 plus X is equal to 360. So X is equal to 360 minus 230. X is equal to 130 degrees. So we can even prove, okay, I will do that in the next class. We'll just stop here. Maybe I'll do the other method quickly. Wait, don't pack. Finish this. Done, online children?
Yes, miss.
Yeah, very good. We'll see the alternate solution. Please draw the diagram again. Alternate solution. My figure may look a little different. Ignore that. It's the same thing actually. 55, 30, 45. 55, 30, 45. Okay, so here we have a construction. Let me draw the figure again. No, sorry. 55, 30, 45. Yeah. So we're just going to join these 2 points. We're just going to join these 2 points. Just draw a line connecting these 2 points. That's possible, no? You can draw a line connecting 2 points, A, C, D, B. A, C, how much is this? D, B. Yeah. All right. You can take this construction or you can take this construction also. 1 second. This one is also fine, or you can take this construction also. You can just produce it down like this. So you can say construction, produce CD to meet AB at E. Produce CD to meet AB at E. Now, what is A? Exterior angle. A is the exterior angle of the triangle AEC. Here. This is the triangle AEC. This is the exterior angle A. This is 55. This is 30. A is equal to 55 plus 30. Exterior angle property. Exterior angle property. So A is equal to 85 degrees. Now this X is again an exterior angle. So we have A plus 45 is equal to X. Same thing, exterior angle property. Exterior angle property. So X is equal to 85 plus 45. X is equal to 130 degrees. Both using exterior angle property in a triangle. Go home and try to understand that better. All right. All right, children, online students, if you're finished writing, that's it for today's session. Thank you so much. Online students can leave the call. Yeah, thank you.
Thank you, ma'am.
Yeah, thank you, children. Good night.
Thank you.
Thank you. Good
Thank
night.
you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.